I wanted to just give you a quick introduction to TypeScript today. So I am, the disclaimer, necessary disclaimer for any presentation. I kind of learned a lot of TypeScript for this myself. It's not all in the slides, but I'm not an expert. Also, I designed this talk kind of for you all. So if you have any questions while I go through, raise your hands. I totally encourage questions. I'm going to skim over a lot of details and show some code snippets. So if anything doesn't make sense, let me know. And I'll either say it's coming up later or explain it. So what is TypeScript? TypeScript is a superset of JavaScript. So what does that mean? It means that any valid JavaScript is also valid TypeScript. By necessity, JavaScript is not typed. So TypeScript is optional types. It's also sometimes called gradual types. So the default unannotated mode is untyped. But you can add annotations and introduce typing to a large untyped JavaScript code base. You really just need to rename the JS files to TS files, and you'll get maybe a few warnings. But then you can start adding annotations kind of surgically and work from there. Or you can start a TypeScript project outright and really design it for TypeScript. It also has some kind of cool features because it is a compile to JS language. So it can transpile features that are in the versions of JavaScript that are not widely supported. So for example, there's ECMAScript 3, ECMAScript 5, and ECMAScript 6, which is being finalized still. But a lot of features are in browsers today. For example, there's a facility for defining classes in TypeScript, which if you're targeting ECMAScript 5, will turn into this kind of like function prototype dance that you see in a lot of JavaScript code today. TypeScript 1.4 came out last week. It was announced last week. And they supported a new target, ECMAScript 6, which is pretty cool. And it has features that I'm not going to get into during this talk. So what are types in TypeScript? TypeScript is, if you're familiar with type systems in other languages, it's probably different from what you're familiar with. TypeScript's type system is structural and not nominal. So a nominal type system is based on names. A structural type system is based on the shape of your data. And I'll get into what that means later. Type inference is also a feature of TypeScript. It's kind of a necessary feature because of the gradual typing rules. It's also a really handy feature because you don't have to write as much typing information into your code. TypeScript also comes with generics, which let you write code that has some interesting benefits, which I will cover in this talk. So this is not everything to say about TypeScript types. This is kind of what I think is maybe the most interesting 3 things to talk to this audience. So structural typing is a little bit different, and so I'm not going to be able to explain everything, but I'll give you a taste for it. So here you'll see that there is a interface. An interface in TypeScript is a way of kind of defining a type. Well, it's like defining the shape of data in JavaScript. And there's also a class. And a class is, defining a class also defines an interface. And it defines a constructor that returns a value of that interface. So a function that can be used as a constructor. Interfaces, this is a note, are generally more useful in TypeScript. Classes can be used, but interfaces are really where it's at. So if I define a variable that is of type named, I can assign a person instance to that variable. And so in a nominal type system, that would not be allowed because named and person are different, and the type checker compares the actual names, the names that I give those pieces of data to those types. But in a structural system, because they both have the same attributes, and those attributes have the same types, I can assign. So that is kind of the main difference there.
Are you allowing questions?
Yeah, please.
So if you go back your slide.
Yep.
So Java would allow this as well?
Java would not allow this unless you defined person to implement the named interface, unless I misremember. And if it did, you wouldn't need to define that person also has a name property, because it would kind of inherit that from the interface.
And so this is possible only because a person has the attribute name.
Right. So the question is, why is this possible? Variable p is defined to be conform to the interface named, and the interface named is really just a shorthand for some structure that has the property name of the type string. And person happens also to be some object with the property name of type string, and so you can assign freely between them. There are assignability has some nuances to it, and thank you. Yeah, thank you. So here you'll see that we have the same interface, some object with the property name of type string, and define the variable x to be of that type, of that shape, and the variable y is an object literal that has a name property that is a string and a location property that is also a string. And TypeScript will infer that the type of that object literal, and I can assign that object literal to x. And so y is like a subtype, or y is assignable to that object. The type, I could have named that type the string, the name string and the location string, but yeah, it's just assignable. It has an extra property. That's fine. If you wanted to use the variable x, you would only be able to know that it has the name property. So the type system has forgotten that information about the data in that referenced by that variable, but the assignability is okay. There's a similar assignability for functions. I'm just going to go past that. And then type inference. So you don't need to define the type of every variable. So for example, TypeScript can figure out that the type of x is number because it knows that 3 is the literal for a number. Somewhat more complicated example, TypeScript comes with a definition file for JavaScript standard library stuff. So window on mouse down, it knows that it's a function that takes an object, which is a mouse event. And so there's a contextual type inference going on. Write the function in the kind of a straight style. And TypeScript will figure out that the mouse event variable, that is the argument to the parameter to that function, should be a mouse event, and mouse event does not have a button property. It's actually a typo. So TypeScript will warn you. It'll generate the JavaScript anyway, but it will say like, hey, this is wrong. Okay. So this is, I think, one of the coolest things about TypeScript, and what excites me most about being able to use TypeScript is generics. Generics allow you to write code that is, well, you can reason about it in a kind of interesting way that I'll get into later. So here is an interface called monoid. Monoid is an algebraic structure. It does follow some laws which are not encoded in the types, but it has kind of two pieces of data inside of it. One is a 0 element, and it has the capability to add, and the law associated is that add is associative. So the interface of monoid is monoid parameterized by some type t. And so I can make, as long as there is a 0 element of that type t, and an add function that takes two values of that type and produces another value of the same type, you have a monoid. And so here's two monoids that both have the same type parameter, but different behaviors. You have the sum and product monoids on number. They have different 0 elements, and they have different, maybe add is not the right word, maybe append, but let's go with add. And then I can write a function that's like reduce, like the JavaScript standard library's reduce function, but uses the structure of a monoid to be more concise. So when I reduce the array of the same numbers using different monoids, I get different results. So you could imagine parameterizing, well, if it's useful. It's very useful. Okay, so generics don't just let you write, it's more than just letting you reuse code. generics have let you exercise this interesting property of code called parametricity. And parametricity gives you proofs for free. It's reasoning about code that is through the idea of being generic. So here are 3 examples. And this is more of a thought experiment. I was thinking about running through the implementations of this, but just as a thought experiment, the first function is parameterized by a type t, and it takes a parameter x of type t and returns a value of type t. Now, barring certain language features, which are perfectly valid in JavaScript, but I would advise against using, there is only one implementation of that function. And I can prove it. Because how could a function that doesn't know anything about its argument generate any value of the same type without just returning its argument? It doesn't know how to construct a value of type t because it doesn't know that type t, it doesn't even know if type t has a constructor. It doesn't know if it's an object type or a number or an array. So it has to use its input to return a value of that type. Now, it could try to cast an arbitrary value into that type. I wouldn't recommend using casts in general. It could have a side effect, but if you eschew those features of the language, you can. It's sometimes called morally reason about this code, if not exactly reason about it. Reverse, similarly, has proofs that you can make about this function. If you defined it to adhere to this type, you would know that it is of the same length as the output list is of the same length as the input list. Although, well, you know that it doesn't insert an element in between. It can't add an element to the list because it doesn't know how to make one. It's probably going to consume the list in some way unless it returns the empty list. You could make the type more complicated to get more proofs. Constant, you could know that it ignores its second argument and returns its first, kind of using the same logic from the first example. But this is a concept that's used more in functional programming, but it's interesting, and I hope I explained it well. So to integrate with third-party JavaScript, which is not in TypeScript, there are what are known as definition files. And definition files don't have any code in them, but they just describe the interface of the JavaScript file in a way that adds types. I'm not going to really get into the syntax for this, but you don't have to write these because other people have done it for you, which is really nice. There are some fallbacks, though, to this having definition files instead of having a pure typed language. One is that you have to trust that the definition files actually describe the library that you're including, because that's not checked. It's just trusted. So TypeScript, when it checks your code, it's only looking at the definition file to say what you can and can't do, what exists and what doesn't exist. So you got to make sure that the person who wrote the definition file wrote it for the right version, that they wrote it well. So it's really not ideal. And of course, if the library changes, the definition file has to update. You can write your own or download someone else's. I would recommend downloading someone else's. And if you can't, I would think hard about what your next step is. It's a major problem with using TypeScript in actuality instead of just in theory. So how do you use definition files given that one kind of huge caveat? Well, the cool kids these days are actually providing TypeScript definition files next to their library. RxJS, the reactive extensions for JavaScript, come with TypeScript definitions. And so if you npm install RxJS, it comes into node modules, and so you know it's correct, which I think is great. Immutable.js, library from Facebook, does the same thing, which is also great, and it makes me feel very positively about those libraries. I hope more people continue that trend. But for everything else, there is definitely typed. It's unofficial, but kind of de facto official. It seems a little uneven. If you just look through the last modified date on some of the files, some of them get 6-7 months old, which is really not great. But if you stick to popular libraries, jQuery, you'll be okay. And there's actually the people that brought you Definitely Typed also bring you a manager that is like bundler, npm, bower for these definitions. It has versioning in it. There's a command line client where you can package them up. It's pretty cool. You can go to the website for more on that. If you want to use TypeScript with Vim, the situation is improving. There is a syntax highlighting plugin, which is cool. It does not have indentation. They pulled indentation out because it's kind of uneven. But there is another plugin that you can pull in. If you're like normal, if you know Vim better than me, you might be able to configure indentation correctly. I had to pull in a plugin. And then there's the cool plugin is Typescript Tools, which integrates with this TypeScript utility that lets you query the compiler for kind of metadata about the state. So you can query, there's a command line utility that lets you say, like, what is the type of the variable at this position in the file. And this Vim plugin communicates with that utility and will, in Vim, you can say, like, what's the type of this variable? And it'll show you in Vim. You can do code completion. It'll show you documentation. And it'll show you what function you need to write, what the parameter types are, and stuff. It does not work in 1.4, which is a bummer. But there's an issue, and it was updated recently. He's working on it. So if you wanted to build a TypeScript project, this isn't like the perfect answer, but this is the best thing that I came up with in the time that I had. The first thing you want to do is you want to install the source map support npm library. It will intercept the exception handling in Node and find the source map and rewrite the backtrace in the exception message to point to the original source files. Super handy. Install just kind of like infects your runtime with that stuff. I'm also using Gulp for this. Gulp is pretty cool. But this is just the Gulp plugins that I'm going to be using the next few slides. I've broken it up over a few slides here. So the first thing is to compile TypeScript. The parameters no external resolve is for the Gulp plugin, but everything else goes to the TypeScript compiler. So I'm targeting ES5. I'm not trying to like write ES6 classes into my produced JavaScript, but I also want to be able to use some features that are only available if you target ES5, like getters and setters. You can write them in TypeScript, but they only are valid if you target ES5. And then the CommonJS module system just means that I can interoperate with Node module, so it outputs Node modules from your TypeScript code. Because I want to be able to use it on the server and the client. And then no implicit any is just saying, if you infer any as a type, warn me, because that's probably not what I want. If you're converting an existing JavaScript code base, you probably don't want that, because you'll just be inundated with warnings. But if you can swing it, I would recommend that as a configuration to the compiler. So yeah, I'm just taking all my source files and the typing definition files that I've pulled in through the TSD utility. And then I'm producing source maps as well alongside. So the source map write, I didn't really dig into it, but I think it sees the relative path and it puts the source, the effect is that it puts the source map next to the compiled JavaScript, named the same with .js.map. And it goes into the build directory. So that's how I would compile them. And then I have a test task that depends on compilation, which reads the compiled JavaScript files and runs them through Mocha. Now I am going into a temp directory using Gulp. I would appreciate if Giancarlo would show me how to do this better with doing it in memory. I couldn't figure it out, but maybe it's possible. And, oh, I should have looked at my last slide. So yeah, hopefully that gives you an idea of how you can start using TypeScript in a project. And gives you enough of a taste of TypeScript to be familiar or be able to more easily dive into a longer format tutorial. I will leave on one note though, which is beware any. Any is the escape hatch of the type system. And in this example, it does not do what you want. It doesn't do what you want because json.parse returns any. Any is the type of any JavaScript value, a number, a string, an object, an array, null. So json.parse returns any, and if any is assignable to any type, and that is I wish that weren't true, but it has to be in order to accept any JavaScript code. So I'm asserting that that edge variable is a number when it is in fact not a number, it is a string. So when I try to square that number, TypeScript's like, oh yeah, this is all fine, the types all check out, but I get not a number. So just be careful about any functions. Don't write functions that return any if you're writing TypeScript and can't avoid it. And if you are using a function that returns any, actually parse it and turn it into the type that it should be. There are more caveats that I'm not going to get into. Any questions?
Can't it tell that JSON.parse will return any? And can it give you a warning that you're taking something that has like a wider type value and trying to assign it to something that you said should be a number specifically?
Yeah, and I wish that it would. And that was my expectation as well. Yeah. And it's like, I just want that to be true. Right. But assignability has that as a special rule for any. And I'm not sure exactly, but I think it's so that you can start with an untyped JavaScript code base, convert it to TypeScript. And this is just, there's so many places in TypeScript where, like JSON.parse, they can't identify what the output is. Right. But
I would never expect it to identify the output. It'd be nice for a warning that says,
yeah.
You're going, if you had done var edge any equals, then it would just be like, okay, he knows he's getting an any. But you're saying
right.
You're expecting a number, and it can't guarantee that. A
right.
warning would be nice.
I agree. Yeah, and it doesn't do that. And I just think that the reason, like there's smart people behind TypeScript, and I think the reason is because if you were converting an untyped JavaScript project to TypeScript, you would just have so many warnings you couldn't even begin. So it's definitely a trade-off. You just have to be careful. There are other similar problems. The function arguments are bivariant, which means that you can assign subtypes and supertypes in an implementation that conforms to the type, which is super confusing. It's easy to get wrong, but so much JavaScript code in the wild couldn't even begin to be converted to TypeScript. Yeah, trade-offs.